Okay, friends, here we go. It is the last week of school before fall break, so let's finish strong. Here are our bell ringers for the week, and I'm going to do just like we did last week. I'm going to do. Okay, so this is our volume activity, I guess you could call it. And remember, we're going to look at layers. And for this one, I want to look at layers starting with this layer in the back, because this is another figure where it looks kind of like stairs. So part of the trick to these is to train your brain to recognize that there are cubes behind these cubes that you cannot see but that still need to be counted. So even though you can't see them, what you can see is this side here. And so that's going to help us count. So we have 1, 2, 3, 4 cubes. Going up, it has a height of 4. And then going across, it's 1, 2, 3, 4. Okay, so it's a 4 by 4. So that means that little piece of it that I shaded red has an area of 16. All right, and then we're going to look at this next section, which is a 3 by 4. So 3 times 4 gives us 12, plus, moving right along, next we have a 2 by 4. So let's see, 2 times 4 gives us 8, plus 4 more. Look at that, it's perfect. It's like a pattern, multiples of 4, but in reverse. That's fun. Okay. Back to black, because I don't want to write with yellow. That would make me crazy. Okay, so now let's see. 8 plus 4 is 12. 12 plus 12 is 24. See how I strategically started with ones that I knew would give me a nice, easy double to add? That was clever of me. Okay, and then 16 plus 24. 6 plus 4 is 10, of course. And then 2 plus, or 20, I should say, plus 10 is 30, plus 10 more, so that gives me a total of 40 cubic units altogether for that figure. One slide each day for you. Okay, some of you probably will want to watch every slide in the video. If it's easy for you and you don't need it, feel free to skip ahead to the next section of the video, one that is more helpful for you. Okay, so let's begin with our daily fact family. Remember, factor times factor equals what? What word do we use to describe the answer to a multiplication problem? It's the product, of course. So 7 times 12 equals 84. Thankfully, we know the commutative property reminds us that we can also do 12 times 7 and still get the same product, 84. Next, we can take our 84, and that is going to become our dividend, or number that we are dividing. 84 divided by 12 will give us 7 in each group. So we're going to do dividend divided by the divisor equals our quotient. Okay, 84 divided by 12 gives us 7 in each group. We could also do 84 divided by 7 and get 12 in each group. Now, if you see your division sign written like this, then your dividend goes inside the division house. Your divisor goes here by the arched part, and then your quotient goes on top. Alternately, you could have dividend, divisor, quotient. All right, moving right along, we have some measurement to tackle. All right, let's see. 7 feet equals how many inches? 7 feet FT stands for feet, times 12 inches in every foot will give us a total of, oh gosh, we just reviewed this, 84 inches. Okay, now we're going to go in the other direction, and we're going to take 108 inches divided by 12 inches in every foot. So with things like this, I just tend to visualize a really tall tree. Okay, so this is a really tall tree. It's 108 inches. That's the abbreviation for inches. 108 inches tall. And we're going to divide that up into feet. And since feet are a smaller unit of measurement, I'm going to have fewer feet per inches. All right, so let's see. I'm going to do partial quotients just because I already have figured out that 7 times 12 is 84. So that means that 8 times 12, let's see, 84 plus 10 will get me 94, plus 2 more will get me 96. All right, so let's build on that. 9 times 12, okay, 96 plus 10 gives me 106, plus 2 more gives me 108. Okay, so that must be 9 feet then. 9 feet and 84 inches. All right, moving right along. Little teeny tiny geometry problem, make it bigger. Okay, name and tell everything you can about the following shape. All right, now I just noticed that I probably should point out to you, name, big fancy word for that is identify, and tell, big fancy word for that is describe. Okay, sometimes in these problems you'll also see them, the people that write these problems will say things like, describe the attributes of this shape. So the attributes are the things that we've been talking about, like the fact that this is a quadrilateral because it has 4 sides. I can see 1, 2 right angles. Now the way that I like to test if something has a right angle is I rip off a corner of a sheet of paper and I just kind of slot the corner of my sheet of paper into the corner of my shape, and if it matches up perfectly, I know I have a 90-degree or a right angle. Now here I have a, looks like an acute angle, 1 acute angle. Let me highlight it and then write it in blue just so I can kind of match up my ideas here. 1 acute or less than 90 degrees angle. And this angle here, it looks like it's just barely obtuse. I kind of want to check it. 1 obtuse spelling angle. Okay, so the way I'm going to check this, let me see if this will work. What if I made a little square? Could I stick this in the corner and see? Yes, see, it's just barely bigger than my 90-degree angle. I was right. I do love being right. Okay, so it's a quadrilateral with 2 right angles, 1 acute angle, 1 obtuse angle. And do you want to know something else that I happen to know about this shape? This is amazing. You're going to love this. Okay. When you have a quadrilateral, the sum of all 4 angles in any quadrilateral, it doesn't matter what 4-sided polygon you're talking about, the sum of all 4 angles in a quadrilateral is always 360 degrees. Isn't that amazing? So if we added up right angle plus right angle, that would give us 180 degrees, plus this blue acute angle here, plus this obtuse angle here, it would equal 360 degrees exactly. It never fails. All right, and the last thing I'm going to say is that I have 1 set of parallel lines. And I will squeeze that into the bottom. One set of parallel lines. And we can remember parallel lines because I always just think of train tracks that run along parallel to one another, always the same exact distance apart from each other, never moving closer together or further apart. All right, moving right along. Okay, this one I was feeling really lazy and I didn't snip it as well as I normally do. I'm sorry. I was just feeling a teeny bit lazy. Okay, so I've got this set of data here. 5, 5, 10, 5, 10, 5, 15, 15, 5. Oh, wow, and a 35. This set of data is probably something weird like, I don't know, number of teeth lost before 5 years old. Just kidding. Nobody could ever lose 35 teeth before they were 5 years old. That's silly. That's ridiculous. Okay. So I'm just making myself a new line for my line plot and not trying to do the straight one because I know I won't be able to fit all my data in there. Let's see, lowest data point is 5, so I'm actually going to start with 0 and go up to 20, just because for whatever reason I like my line plots to have really even intervals. It's going to bug me if I start with 5, but you could start with 5. If you wanted to, you could have your line plot start at 5 and only go up to 35. Although, look, I'm already making a mistake because my biggest data point is 35, so actually I should go up to 40. This will be 20. This will be 10. This will be 30. Okay, do you guys know the secret of drawing lines to get the right number of spaces? If you need 5 equal spaces, draw 4 lines. So spaces, lines. If you need 6 equal spaces, draw 5 lines. If you need 7 spaces, draw 6 lines. This little piece of information, you have no idea how handy it's going to come in your life. You're going to be so happy I taught you that. Okay, so 1, 2, 3, 3 5s. 1, 2, 10s. Oh, another 5 that I missed. 1, 2, more 5s. A 15. And a 35 all the way over here. Okay, so I don't know if I've taught you this word yet, but I'm going to teach it to you now. This data point, because it's kind of far away from the other data and it seems like it might represent a surprising piece of data, we would call that an outlier. Like an odd or surprising piece of data that we weren't really expecting. And then this piece of data here, our 5, all of our 5s, that would be our mode, because that's our most commonly and frequently occurring piece of data. And then our range is between 5 and 35. All right, and that's it. Wow, that was fast today. All right, hope you guys enjoyed that.